My name is Aurimas. I'm at Google. I work on AndroidX libraries. If you've written Android apps, you probably accidentally touched something that I worked on. So yeah, thanks. Let's get started. So who's the target audience? Hopefully you use Gradle. If you don't, this is not going to be super helpful. So if you want to go grab a beer, that's fine. You probably have a build team. If you don't, you probably don't care about making your builds more strict. You care about consistency of the things you ship. So if you work on a larger team, this becomes bigger and bigger problem because you want to make sure all of your libraries and all of your applications and all of them are kind of like aligned and they're doing the thing that you want to do. And then finally, you can't really keep up with every build.gradle change. So if it's AI generating new PRs, or if it's your team has grown to a size where you can't review everything, and you're starting a feeling that things are slipping through your hands and things are going in the kind of the wrong direction, you're in the right room. You're going to hear a little bit about the kind of things you can do. All right, so as you might have heard, this quote of great power comes great responsibility. So I feel like Spider-Man had really captured it. And what you do is, as you have a lot of things you can do, sometimes it comes at the kind of cost of complexity, cost of maintenance, and cost of that stuff. And the quote from me is Gradle is very powerful, which in my mind, that means that it is also very complex and sometimes, and you have a lot of responsibility on your shoulders to make sure your build is doing exactly what you want it to do. So I'm going to walk through a couple of strategies, slowly ratcheting up in kind of strictness, and we can see what you can do to kind of make sure that you're controlling the build that you care about. So one really amazing thing is to rely on the fact that all the developers are lazy, right? What they do is if you put them no place to put the build logic, they're most likely not going to do something, right? So the idea is if you can use convention plugins or just binary plugins in general, you're going to reduce the boilerplate and essentially lower down the entry of where you can put something in there. And so that's kind of like the easiest thing. And this is like the lowest level of strictness because you're not really enforcing anything. You're just taking away places where to put code and people will just not put code. So if you look at this slide and you don't see anything, that's intentional. This is like a basic Android library, or actually Android library plugin, or Android library build file that has a configuration that's kind of out of the box. If you generated one in Android Studio, that's what you would get. And all of these things are very verbose because Android Studio team wants you to change things. You want you to configure it. Maybe you want to change a Java version. Maybe you want to change something else. It gives you all these opportunities. And if you give this to your developer working on a product, they're going to go and change these numbers, right? Like that's just a natural human instinct. And what's better is you kind of strip everything out into a convention plugin and you only leave the bits that they should be touching. Right, so the plugin will do this heavy lifting, and here I called it fancy plugin. It will go and do the work that you want it to do. And the developers are only left with the bits they're kind of allowed to touch. There's dependencies that you can go and let them do whatever they want to do. And then maybe you expose them a couple of toggles that they can go and set. And when you set these toggles, it does the things that you want them to do. And so you didn't really rip anything out from their hands. They can still go and add a little Android block or a little Kotlin block, whatever. They can go and do that. But now they have to really think about it. I'm like, oh, how would I go and configure a Java version for an Android project, right? They have to do a work. And because they're lazy, they're most likely not going to do anything. So the other thing you can do, and we're ratcheting up the strictness a little bit, is that you can let machines help you in figuring out which changes need to be reviewed. What I mean by that is when you really simplify your build and your build file only has dependencies and your little DSL block you've introduced yourself, you really don't need to review most of those files anymore, right? Because it's making changes that are totally fine and totally reasonable and you don't have to do anything. But what if someone adds something outside of it? Can we catch those type of things? And you can, right? So if someone, let's say, goes and adds an Android block back in and sets the compile SDK to be 36, and you as a company have decided you're not ready for that and it should be 35, what you can do is essentially you can detect that and then use it as a trigger to do something else. And what I mean by this, in GitHub, for example, you can go and set it up a pattern that will just use a GitHub action to trigger an add to reviewer, right? So now for any changes that go outside of the dependencies block and then the block that you defined, you will get an additional reviewer. And if you find that super important, you can even get to the point where you have to get approval from those people, not just add them to review. And it's kind of like a little nudge towards enforcing to do the thing that you wanted to do. So kind of keep ratcheting up, the next thing in kind of like, I would say, medium level of strictness is enforcing that certain values that are using Gradle property API are essentially locked down and users are unable to modify. So if you know, in most of modern plugins these days, you use properties to define their DSL. And in this example, Kotlin Gradle Plugin has a way to set the JVM target. And the user can just set it in their build.gradle file, and that's kind of how it works. And what you can do, though, is when these property files are properties are exposed, you can essentially lock them down. There's two methods that you want to use. You want to set them, which is kind of the standard thing, and that's what gets invoked when you have your build.gradle file. But you can also say disallow changes. And what that means is that after that's set, nobody is allowed to change that property again. And you essentially write yourself a little extension function, and you can just use it then, right? You get in your plugin the extension, you set it to be Java 8, and then nobody is able to change it to a different value. And if they try to do that, the build will fail, and you will get an exception saying, okay, you can't change it. I wouldn't leave a message that short. I wanted to have it short for the slides, but normally you would probably want to explain, okay, in our company, we can't do Java 10 or 11 or 21 or whatever the number is because reasons X, Y, Z. But now you're like really kind of ramping on and like not allowing them to do the things that they might want to do. Some plugins, like Android Gradle Plugin, doesn't actually expose properties in their DSL. Instead, they use primitives like strings and integers and so on. And so you don't have this ability to just say disallow changes. But Android Gradle Plugin luckily exposes a method for you to go about and lock it using a different mechanism. What you can do is there's a lifecycle call called finalize DSL that Android Gradle Plugin calls right before it configures the rest of your build. And that gives you an opportunity to essentially finalize things that you want to be set in a specific way. And if you set this up, when the user goes and sets it in their build.gradle file, it will just do nothing because you have overridden it in your plugin and it will be no effect. If you do want to make it clear to the user that their value doesn't do anything, you can also throw an exception. You can simply read the value and just return saying you cannot modify it. It has to be 36 because that's what we decided as a company. All right. And now we get to the point of like what happens to all the other plugins. What if you're using something that's kind of more legacy and doesn't have the lifecycle method of finalize DSL and it doesn't use properties? So you can use after evaluate, which normally I would say never use it, but this is one of a few cases where I think it's a last resort tool they can use to actually do this work. So what you can do, you can get a Java extension, and then the after evaluate set this value. And so when a user tries to set this in their own build.gradle files, it will have no effect. And similarly, if you do want to make it very clear to the user they're not allowed to touch it, you can also throw an exception and make it very clear to them that they're not allowed to set their Java version to 11. And then you might ask, what about creative build.gradle files? Because I'm sure many of you have looked at it and you're like, I feel like I know how to work around that. And if someone does that, where they put an after evaluate and they put a finalized DSL inside of it, all of my enforcement just goes out the window. And then similarly, if someone puts an after evaluate inside of an after evaluate, then you can go as deep as you want beyond that. It also breaks this, right? Because now you're hooking into a cycle that's slightly later, and you're able to break all these enforcements. For that, we kind of are cranking into a medium-high category of strictness, and we need to essentially create validation tasks. So instead of doing this enforcement at configuration time, we can do it during task execution. And an example of this, we could write a task that can enforce a test runner that is used for your projects that are Android projects. All you need to do is create a pretty basic task. It has a property that's a string, and then you can assert that that string is exactly the value you expect. So, pretty simple task here. And what you do is when you configure your project, you essentially wrap the value of the DSL inside of a provider. And what that does is it will not read that value at the time, but instead will be read when this value is being used by the task. So then you wire this wrapper of a provider that reads the instrumentation runner. And so when the task is executing, that's when it's going to read the value. And so you know that you're getting the very, very, very final version of it. And so when a user goes and tries to change it to something else, you can essentially fail that task, right? And you can put that to be part of your validation task or some sort of enforcement that you start running, and you will fail the build. All right. What if we want to go even further and we just keep cranking that dial even further? We can do even better by validating the outputs of tasks that you care about. So for example, if you have something that produces an AAR for an Android library or a jar for a Java project, you can actually validate the artifacts themselves. And what would that look like? So for example, if you decided as a company that minimum SDK version for your Android library is 24, you can actually make sure and enforce that that value inside of the AAR file, the manifest file, in fact, is 24. So what you need to do here is you just consume the artifact, which is the finalized manifest location, and then you can do an assertion, so contains. This is like a very primitive check, but you can go as clever as you'd like. You can use XML parsing libraries and so on, but like I did something very basic just to kind of prove a point here. And then when you're setting it up, all you have to do is to pass the finalized artifact into this task. And so when you are running this enforcement, it will in fact catch that. And if a user tries to set that value to something else, it will go and fail when the task is being executed, right? So like now we're going even further, right? Like what about validating build.gradle files themselves, which essentially allows you to be even more strict on this work. So what you can do is you can just write a simple task and it just takes the build file itself as an input and you can parse it. You can use ASM, PSI, pick your favorite tool to analyze the file you have. Or in here, I just took a very basic thing where like I just don't allow a Kotlin block inside of the build.gradle file because we just don't want to allow that as an organization. And then what you do is you create this new task and you just pass in the file that you expect and you want to enforce. And so when a user runs it, if they put a little Kotlin block inside of their thing, the task will fail and you can explain to the user why they're not allowed to do this because the plugin does it or if there's team enforcement or something like that. If you use Groovy instead of Kotlin script, you can actually use Nebula lint to do some of this enforcement in a slightly nicer way. So if you heard a talk by Netflix, you probably saw some of the tools they provide. So essentially, you can write your own custom check, and that will give you a nice ASM language, enforcement that you can actually traverse and do slightly more clever enforcements. All right. Now, if we go to the extreme version of enforcing things, what is the most extreme? Like if you think about it, like what would that look like for you? And for me, the most extreme is where you take away all the knobs and all the user's left with is only the stuff they're allowed to touch. So welcome to build.json, right? You can have a thing that specifies what this is and whatever they're allowed to do. And in this case, they're allowed to choose a type and they're allowed to choose dependencies. And then nothing else developer is able to control because there's no build.gradle file, there's no build.gradle KTS, there's no anything else wherever they can put it on it. And if they put the values that are not relevant, it will not be read, right? So this is kind of like the most extreme way of like, you're only allowed to touch the things you do. And this, as we talked earlier, great power comes great responsibility. This removes ability for developers to accidentally do a thing that is going to break your organization because they're only able to do the things that the thing exposes. So it's kind of like the trade-off. And you look at it, you might be like, oh my God, like this seems like a nightmare to maintain. I wouldn't want to have this kind of thing. And hopefully in a couple of slides, you'll realize that it's actually not that difficult. So let's start, right? If you've ever used Moshi library, it's actually very easy to parse JSON. This is kind of like all we need on a slide to be able to define the model, what's inside of your JSON. Parsing it is also fairly simple. You just simply read the file, and then you pass it into the JSON adapter, and then you get the data class out of it. And then you're able to do whatever you need to do for the rest of the configuration. And then when you have the configuration data class, you can then do things. If it's an Android library, do this thing. If it is an Android application, do this other thing. If it's a Java library, do this other thing. And then it allows you to essentially just do the things that user defined and the only things they can control. And if we jump in and what would it look like if you jump into the Android setup? You can, for example, configure Kotlin. You can apply the Android plugin. You can configure whatever common options. And then here, you can also add all of these dependencies over from the JSON file where the user defined it into the actual dependencies in the configuration that's called implementation. So users don't directly interact with that configuration, and thus they're not able to make changes that they're not expected to. And then finally, this is not the most clean way of applying this, but what you can do is essentially have a mechanism that goes and applies this plugin across the whole project, you can put it inside of all projects in the root project, or you can put it inside of Gradle.before projects inside of settings.gradle, which would be IP compatible. So you can have a logic, and you can do partial conversion, where you have essentially a logic of, oh, well, I converted 20 modules in my library in my project to be strict, and then the other ones are still using build.gradle, and now you're able to do this migration slowly. And that's kind of it. Now you have an extremely strict version of your build definition that nobody else can change. And if you think about it, there's other formats. You don't need to be using JSON. If you, in particular, everyone hates one of the configuration languages. If you hate JSON, pick YAML, right? It looks, in my mind, slightly cleaner. Or you can go pick XML if you are, if you like to torture yourself. Or you can go use JSON 5. You can use Starlark. You can use Toml. I mean, pick your favorite format. Anything you can parse, you can build a project out of it. And that's kind of the idea. And then you're like, okay, could Gradle support this natively? It feels like it would be a nice thing that Gradle would just do out of the box, and you don't have to maintain any of these models and any of this setup and any of the linking. And Gradle kind of does. So if you looked at a declarative Gradle project, it is a project that allows you to do exactly that. You kind of define your software type and all of the things you want it to touch. And this is an example of what their example for a Java project. But essentially, you can define your custom DSL, and users are only able to touch the values that you're exposed. The sad part is it's still in EAP. There's been in EAP for a year now, and I believe that there still has a fairly long road ahead before you can use it. So, take it what you will. So what have we learned? What are the takeaways? I think there's many ways to enforce consistency, and you kind of saw it through the slides. You can kind of go from as little of strictness to the maximum amount of strictness, and you can kind of pick for your project what you need. As your build grows, you're most likely going to get stricter. So AndroidX, where we build thousands of libraries in a single repository, we're definitely leaning towards stricter and stricter type of setup. And then you kind of want to pick the strictness based on the level of severity of making a mistake. If you moving your project accidentally to Java 21 as a default target is extremely bad for your business, that's the thing you want to focus on and make sure that that's the part that is strict first. So just kind of pick your battles and choose what you need to do. And then finally, hopefully you're now convinced that you don't really need build.gradle or build.gradle.kts to configure a project. You can use anything. There doesn't need to be a file. In fact, I've even seen some folks poking around where you can actually use a Java module system to not have any files and defining your dependencies inside of that way as well. So what didn't we talk about? Because there's so many ways to do strictness. Dependency locking, substitution, blocking. You probably saw that talk from Netflix. I would recommend you just kind of review that as well. Versioning of projects. How do you set it up? Do you want to version it across the organization in a certain way? We didn't talk about that. How about locking of which repositories I use? It's most likely that you don't want every project poking at every random repository, and you might want to enforce that as well. Maybe you want to allow a list of which Gradle plugins are allowed, because some of them are, doing something you shouldn't allow in your organization. And then there's, static analysis of Gradle plugins, and on and on and on. And there's a lot of things. To make things easier, I created a very, very, very simple and small GitHub repo. If you wanted to take a look, the things I walked through the slide are all in there. This is my dog, Billy. He's awesome. And yeah, thank you for your time. And if you have any questions at all, I'll be outside and happy to talk to you about the strictness of Gradle builds.